Welcome to this explainer. Today we are going to trace the invisible engine that powers all of human progress. And honestly, it's an engine that is entirely dictated by a massive geographic lottery. We're talking about the completely unequal, totally fascinating distribution of natural resources across our planet. We are going to dig into the bedrock of global wealth, look at the fuels that built our past, and uncover the extremely rare elements that are quite literally dictating our future. To really grasp the stakes of this geographic lottery, I want you to just think about this number for a second. 17. That's it. There are exactly 17 rare earth elements that completely control our modern technology. From the screen you're watching this on right now to the vehicles we drive, absolutely everything hinges on exactly where these 17 elements happen to be buried. Okay, so let's map out our journey today. First, we'll cover the foundations of global wealth. Then, we'll shift into the fossil fuel engine, followed by unconventional and future fuels. After that, we'll dive into powering modern technology, and finally, we'll take a trip down to the deep sea frontier. All right, let's jump right into part 1, Foundations of Global Wealth. So long before complex technology came around, human industry had to rely on what was right beneath our feet. And coal? Well, it doesn't just appear out of nowhere. It requires Mother Nature's millions of years pressure cooker sequence. It starts out at stage 1 as peat, which is this fibrous, soft, spongy stuff where you can still recognize the plant remains. Then, as pressure cranks up, it transforms into lignite, this brown coal that just crumbles in your hands. Squeeze it even more, and we get bituminous, a soft black coal. Until finally, at stage 4, boom, we get highly compressed anthracite. That is a hard coal that burns really hot, with a super short flame and almost zero smoke. It's just a perfect example of how time and intense geology work together to create raw energy density. Now, alongside coal, we have the other heavy hitter of global infrastructure, iron ore. But here's the thing. Just like coal, iron ore is absolutely not created equal. The geologic lottery completely dictates the quality of your raw materials. Like, if your nation is sitting on magnetite, congratulations, you are pulling over 74% pure iron right out of the dirt. But compare that to siderite, which yields under 50%. I mean, imagine trying to build a massive railway or city grid, but your rocks literally force you to do twice the work to get the exact same amount of steel. The type of rock beneath your feet drastically shifts the entire economics of building a nation.
Moving right along to part 2, the fossil fuel engine.
So, transitioning from those heavy, solid rocks, we enter the era that really defined modern geopolitics and transportation, the age of liquids and gases. And there is this fascinating head-to-head matchup in the oil world between sweet and sour crude. It just perfectly proves how a single geographic quirk can alter a nation's destiny. Sweet crude, which is super abundant in places like Iraq, requires way less energy to extract and refines beautifully into high-quality gasoline. It's the VIP of oil. On the flip side, you have sour crude. Countries like Venezuela have massive reserves of this stuff, but it is just packed with impurities, mostly sulfur, which makes it incredibly difficult and expensive to process. And then, when it comes to natural gas, which, by the way, forms when layers of ancient buried plants and animals get exposed to intense heat and pressure over millennia, the geographic lottery is incredibly tight. Global dominance is heavily, and I mean heavily, concentrated in just 5 nations: Russia, Iran, Qatar, the United States, and Saudi Arabia. Honestly, if you want to understand global energy negotiations, the whole shebang pretty much traces back to this one highly exclusive list. Which brings us to part 3, unconventional and future fuels. Now, as those traditional, easy-to-reach wells inevitably start to dry up, human ingenuity has had to push us towards some pretty unconventional extraction methods. Take shale gas, for example, which is stubbornly trapped tightly inside sedimentary rock. When we shift our focus to shale, the geopolitical map just flips entirely. Suddenly, China emerges as the heavyweight champion with an estimated 1,115 trillion cubic feet of reserves, followed closely by the United States and Argentina. But if you think shale is wild, wait until we talk about methane hydrates. This sounds straight out of science fiction, but it is very real. Imagine a cage-like lattice of ice, found deep down on the seabed where the temperatures are freezing and the pressures are just crushing. Inside these actual, literal cages of ice are trapped molecules of combustible methane gas. It's a massive, highly complex potential energy source that's just sitting there, waiting beneath the ocean floor. Let's shift gears into part 4. Powering modern technology. Leaving fossil fuels in the rearview mirror for a second, we have to talk about the nuclear fuel supply, because it is wildly imbalanced. When you look at uranium production from mines, a staggering 42% comes from just one country, Kazakhstan. Throw in Australia and Canada, and you realize that over 3/4 of the entire global supply is completely cornered by just 3 nations. But hold on, because those nuclear power dynamics might be on the verge of a major shakeup, and it all comes down to this number, 25%. That is the chunk of the world's thorium reserves held by India alone. And here's the kicker. Thorium is about 3.5 times more common in the Earth's crust than uranium. As nuclear technology evolves to actually utilize thorium, India's geographic luck could easily make it a central, dominant player in global clean energy.
Okay, remember that number 17 from the very beginning of our explainer? It might have sounded a bit abstract then, but those 17 rare earth elements are the invisible anchors of your everyday routine. Just think about your home right now. Yttrium is literally giving you the vibrant red colors on your television screen. Neodymium, that makes the permanent magnets that allow your cell phone speakers and headphones to actually produce sound. Gadolinium is sitting quietly inside your USB flash drives. Cerium is out in your driveway right now, actively reducing emissions in your car. And scandium is giving crucial strength to the aluminum alloy in your bicycle frame. These elements aren't just obscure rocks. They are the fundamental building blocks of modern life.
And that brings us to our final frontier. Part 5, the deep sea. Our absolute insatiable hunger for these crucial tech elements is pushing human engineering to its ultimate extreme. Down at the crushing depths of 4,000 to 6,500 meters below the surface, we find polymetallic nodules. These are literal rounded rocks made of incredibly valuable minerals like manganese and iron, plus crucial tech metals like cobalt and nickel. And they are literally just sitting there, covering vast, dark areas of the ocean floor. But getting them up to the surface, that requires a massive, complex mechanical ballet. It starts with a huge seafloor collector, roaming the dark depths, basically acting like a giant vacuum for these nodules. Then a massive slurry pump has to forcefully push all this heavy material miles straight up through a riser pipe to a specialized mining ship floating on the surface. That ship processes the haul, and finally, return pipes send all the leftover water and tailings all the way back down to the ocean bed. But as we target this completely untouched, mineral-rich frontier to power our high-tech, sustainable future, we're left with a really heavy question. Knowing the severe, potentially irreversible impact that deep-sea mining could have on totally fragile underwater ecosystems, is the treasure trove of the deep sea a price we are actually willing to pay?